Today we are going to be talking about water health. Did you know that there's 0.3% usable water on the earth? Today we're going to be talking about why water quality is tested, the different ways water quality can be tested, and the practical applications of water quality assessment in agriculture. So first, why is water quality tested? One of the first reasons is for environmental protection. We test water quality to prevent the spread of invasive species and to ensure that our waterways are healthy and usable for recreational and wildlife purposes. It's also the law. Under the Clean Water Act, water quality must be tested and maintained, and under the Kentucky Water Quality Act, any farmland or agriculturalist that has more than 10 acres has to submit a water quality plan in order to ensure that water stays clean. We also test water quality to prevent potential hazards, and that can come in the form of chemical spills, runoff, or physical pollutants. So spills can be like the spill you see in the top right corner there, which could be an oil spill. We also have runoff from fertilizers and detergents like phosphates from laundry detergents and soaps, and also physical pollutants that can be harmful to wildlife. Now let's talk about some of the different water quality testing methods. There are many different methods that we can use to get a good indicator of water quality, and the first is pH. The pH is the number of dissolved hydrogen ions in the water, and that can give us a good indicator of how acidic or how basic our water is and what can live in there. So I have a range here up at the top right hand corner, and this test, after you add the chemicals in, will show you what the pH of the water is and whether your pH is high or low. An acidic pH is things like beer, things like fruit juices, and then a basic pH would be things like bleach or like baking soda or things like that. The next is conductivity, and that is the amount of dissolved metals within the water, and that gives us a really good indicator of how conductive the water can be for different purposes and different uses. The next is dissolved oxygen, and dissolved oxygen is a really great indicator of how much life can actually live in a potential body of water. So generally the range for animals and wildlife is generally somewhere between 6 and 8, and anything higher than that generally supports way too abundant fish populations or way too abundant life populations, and anything below that is too low to have different populations. So the next thing that we can do is take a biological sample, and that would be taking different aquatic macroinvertebrate species. So this picture here is what we like to call a booger bug or a crane fly larva. Different species are good indicators of good and bad water quality. So stoneflies, mayflies, caddisflies are all great indicators of water quality. We can also do a site-based test that we can look at the water and determine water quality. We can look at scents for different pollutants. We can also look at the turbidity, which is the amount that you can see down in the water to know how many dissolved solids are within the water and how clean it is for different uses, as in water quality or things like that. So let's talk about some of the practical applications. So the first would be irrigation. So we want to ensure that our water quality is good not only for what we're irrigating our crops for, but we also want to make sure that we don't have any runoff of potential pollutants that will get into our waterways via fertilizer. So we don't want fertilizers in the waterways that can cause eutrophication of water. And we also have to use water for our cattle and our horses, and we want to make sure that we keep contaminants out of there as well. In addition to this, we also want to make sure that we keep contaminants out of our waterways from these agricultural purposes. So we want to keep manure runoff to a minimum, because not only can that cause eutrophication, but it can also cause potential hazards in drinking water. In addition to that, things that we can do to keep those things out, or we can provide buffer strips or riparian zones, which is a strip of potential vegetation that it almost acts like a straw and it'll suck up that vegetation, or we can implement geotextile fabrics in heavy use areas to prevent runoff. We also have practical applications for swimming, so primary contact recreation and secondary contact recreation. We want to make sure that our waterways are healthy. We also want to make sure that we have adequate water use for hunting and wildlife habitats. So any steps that are taken to protect and conserve water is called conservation measures, and there are many different campaigns and policies and best management practices out there, like we talked about riparian zones, to provide those conservation measures. But that's just a little bit about water quality. Thank you all so much.